We kind of have like this story problem where we're going to talk about, well, let me read the problem, then we'll make a graph. We're going to use a graph, and we want to make, it involves an aquarium. So you want to set up an aquarium and need to determine what size tank to buy. We're going to draw a graph, and the graph's going to show the tank sizes using a rule that relates the capacity of the tank to the combined lengths of the fish it can hold. If you want 5 2-inch fish and 4 1-inch fish and 3 inch and 1 3-inch fish, what's the smallest capacity tank you can buy? A 15, 20, or 25 gallon. So let's write down some of the stuff. It says we're going to have 2 1-inch fish, 3, or no wait, we're going to buy 5 of those. So I read that wrong. We're going to buy 5 2-inch fish. So that's a 2-inch fish. So this is going to be our quantity of fish, and this is going to be the measurement in inches. And then we're going to buy 4, God bless you, 1-inch fish, and then we're going to buy 1 3-inch fish. Okay? And we need to know how big the tank needs to be. And so we've got 2, 4, 6, 8, 10. And then over here we've got 2, 4, 6, 8, 10. And so the textbook gives us this chart. Now this chart is another way to represent that data that we kind of almost did on the last problem. But this is a little different. So I come in here and it has a y-intercept at 0, 2. And then at 10, it's 9, 10. So 9, 10 here. And so we're going to have like a line that goes from here to here. So that's our line. And we're trying to figure out like how big, and this represents the combined length. Oops. So this is the combined length of the fish. Okay, and this right here is the capacity in gallons of the tank. How do I do this? Yes.
So you have to add up the total length of all the fish you're getting, and then you'll find that on the combined length part of the graph, and you'll go up to where it intersects on the line.
Okay, he's right. So now what is the combined length? I have 5 2-inch fish, so could I do this? Could I say 5 times 2 plus 4 times 1 plus 1 times 3? So this is going to be 10 plus 15, plus 4 plus 3. Now what's that total?
17.
17 inches. Okay, what do you notice about the chart?
It only goes to 10.
Only goes to 10. Uh-oh, SpaghettiOs. What do we do?
Add more, make it bigger.
We make the chart bigger, or what? Does anybody know? Find out the mathematical relationship. What kind of graph is that? You guys have had Algebra 1. Yes?
It's a linear.
It's a linear. Now, what's the formula for linear graphs? Yes?
Y equals mx plus b.
Y equals mx plus b. So I'm gonna jump over to another page here. And so we know that that's a linear graph, and we can represent that by y equals mx plus b. A little math review for you guys. What does m represent? Yes?
Slope.
Slope, which is, what's another way to say that?
Rise over run.
Rise over run. What's a real formal math way to say that?
Ratio.
Yes?
Change of y over the change in x.
Yeah, or Mr. Adams will say delta y over delta x. Change in y over change in x. This is the Greek letter delta. It's not a triangle. It's the Greek letter delta, and that represents change. So it is the change in y over the change in x. Well, that's cool. What's this b represent? Yes?
Y-intercept.
Y-intercept. All right. So now if I know the y-intercept and the slope, by the way, what do we call this representation? I thought I heard it. This is known as the slope intercept form of a linear equation. Now, if I go back to this, can I figure out what the slope is?
Yeah.
Can I figure out what the y-intercept is? Well, let's start with the y-intercept. This is the y-axis, and it crosses at 0, 2. So the y-intercept is the y-coordinate of where it crosses the y-axis, or 2. In other words, b equals 2. You guys with me so far? All right. Now the rise over run, this point right here is actually 9, 10. So, delta y over delta x is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Is there anybody in here that does not know what I've written on the board? All right, so the y sub 2, the subset notation, that's just letting me know that I have an x here. So we'll call those x sub 1, y sub 1, because that's the first x and y. And then over here, I've got a second x and a second y. And Mr. Adams always used the subset notation. Why? Because, well, you're going to need it in precalculus and calculus. But I'll just say x sub 1, y sub 1, or x sub 2, y sub 2. So when I plug this in the formula, I'm really going to say 10 minus 2 all over 9 minus 0. Is that 8 over 9? Oh, wait. Yeah, that's right. 8 over 9. Well, let's hope I graphed this correctly. All right, so now let's go back. Y equals, what was our slope?
8 over 9.
8 over 9 x plus, what was our y-intercept? 2. All right, let's do this. You guys ready for this?
Yeah.
What was the x, the independent variable? What did that represent on the graph?
Length, combined length.
Combined length. What did we say the combined length was?
17.
17. So what do I plug in my formula here?
17.
17. So I'm going to say y is equal to 8 over 9 times 17 plus 2. What was the numbers?
8
8
over
over
9
9
times 17 plus 2.
All right, so we're going to say 8 times 17 divided by 9, right? Plus 2. Whoops. Plus 2. 17.11, roughly. Yeah. Now, the original question was, do we need a 15, 20, or 25-gallon tank? What would you guys say?
20.
So we need a 20-gallon tank. I'm going to do some other things, too, though. We said, oh, wow. You told Mr. Adams was doing some complicated math last class. Let's change some of this stuff. We want function. We want real numbers. All right, what do we got? Okay, cool. I want to verify this. I want to verify that. I said, what did that equation represent? Where did that equation come from? What does that equation do for us? Where did Mr. Adams get that? I just made that up? You think so? Boy, we covered an awful lot in this one example. What does that equation represent? Let me remind you, it represents that line. We said that this graph was a linear graph, and we could represent that mathematical relationship because it's linear. We know that a linear equation is going to be in the form of y equals mx plus b. And we went back and we did the math, and we said it was 8 over 9x plus 2. So, the one way that I could verify that is I could take my calculator, okay? You guys get your calculators out, click on y equals, and I'm going to see if this works. I'm going to start parentheses, 8 divided by 9 times x plus 2. Then what I want you to do is hit window, and we went from negative 12, whoops, not that far, negative 12, actually for our minimum we went from negative 1, so put negative 1, whoops, Mr. Adams is a little happy there on the, getting a little excited. We'll go from x max to 12, and then for the y we'll do negative 1 to 12. Okay? Now I'm going to hit graph. Let's see what we get. Okay, that kind of looks like what we had on Mr. Adams. It's a little distorted because it's not perfect. Notice that my x scale and my y scale are a little different. Let me go back and see if I can fix that. No, it's the same. It's okay. There's not a whole lot you can do. The calculators are off a little bit. So now how can I verify this data with the data that I had from the book? Check the points. So now I want you guys to hit this gray button that says trace. Now when x equals 0, what did y equal according to our graph? Look at your notes. Yes?
2.
2. So if I plug in x equals 0, when I hit enter, what number should we expect to see? 2. Let's see. Yep, that worked out. Now what was the other point that we used? No?
9, 10.
9, 10. 9 comma 10, right? So if I plug in 9,
Should get 10.
I should get 10. Let's hope and pray. All right, good. Now, if I zoom out a little bit, if I hit zoom out, how do I want to verify this graphically? What was the combined length of all the fish? Yes?
17.
17 inches. So remember a couple of things. Remember that on our graph from the book, this represented the combined length of the fish. So our x-axis represented the combined length of the fish. What did this represent over here? The capacity of the tank. In other words, our y-coordinate tells us how many gallons the tank needs to be, while the x-coordinate tells us the combined length of the fish. And so we had 17. So I'm going to plug in 17. Whoops. I got to graph it. And then I got to hit trace again to let the calculator know that I'm interested in x equals 17. Now when I hit enter, I get 17.11. So we're almost done answering this question. Now why did Mr. Adams do the same problem 3 times?
Because we need to know it's 7.
Yeah, because when I do research at Northwestern, I don't know what the answer is because I don't have the back of the book. So one way that I can practice to see if my answer is correct, I do the same problem 3 different ways. And if all the numbers are the same the 3 different ways, then I'm pretty confident that I have the right answer. It's great practice to have. Now when you take the SAT, we're going to do so many of these problems, and you're going to know how to do the stuff forward and backwards. You won't have the answers for the SAT either. So you'll graph it real quick, you'll do the math real quick, and as long as the numbers match up, you probably have the right answer, right? Or you're really, really wrong, right? But the odds are you're probably correct. So, the question was, originally, how big of a tank did you need? So, we had to choose between 15 gallons 20 gallons and 25 gallons. And you guys, what side did we agree on?
20.
20 would be enough. 20 would be sufficient. Technically, we need at least 17.11 gallons based on our equation, right? And that's based on the fact that y equals 8 over 9. Whoops. And we had a combined length of 17 inches, which gave us the 17.11 gallon. Are there any questions on that?